Hello, today I would like to discuss 2025 May Physics Paper 1A. This is time zone 3, basically for Asia, including China. Or if you don't know which question paper I am going to discuss, these are the first two questions, so you can have a look. And this is the paper. I'll start immediately. Now, to do question number 1, we need to understand how we define velocity. Velocity is, we write this type of mathematical equation, right? But if you look at this part, delta over delta, delta time, delta t. If I ask delta over delta t, explain this one in words, you will say this is rate of change, right? And second thing is this s. What is this s? This is displacement. So the word displacement should be there. Also, there should be rate of change of concept. This is displacement is there. Position is also displacement, but this one has the word distance. This one has the word distance, so I remove these two. Second one, why answer A is wrong? This means V is S over T. It is wrong. It is delta S over delta T. So answer should be B. Question number 2. The thing you have to be careful here is the time. Time is only up to 8 seconds. So they are basically focusing what is happening in this region, right? Now, second thing is, even though we are not very familiar, acceleration is delta V over delta T. So delta V is acceleration times time or area under graph. This is what we are not very familiar with sometimes. So, and second thing is, this starts from rest. So V minus U is the area under graph, 8 times 8 over 2. So this comes to 32. As the motion starts from rest, V minus 0 is 32. V is 32 meters per second. Answer should be B. Question number 3. This object experiences two forces. One force is F, but F you can resolve into two components. This horizontal part can be written should be written as F sine theta. Vertical part in this case is F cosine theta. So what is the other force? Other force is our familiar, the weight of the object, or you can mark it as mg. Now let's write F equals F net force is ma. I am going to write it upwards. Upward force is F cosine theta. Mg is downward, so minus mg is m times a. So acceleration A equals F cosine theta minus mg over m. If you look at this, you can find the answer as answer A. Question number 4. Question number 4 is about upthrust. Let's think about an object which is immersed in a liquid. There are two forces on this. One is the weight of the object, but our focus here is the upthrust. It is given as V rho G. Two things to be careful. This V is volume of the object. Also, this rho means density of liquid, not the object, liquid. So based on that first equation, let's think this is F1, or you can call it U1. Sorry, in the marking question it says F or U. So F equals or U equals V rho G. Volume of a sphere is 4 over 3 pi r to the power of 3 rho G. Let's take it as equation 1. Second sphere has radius only r over 2. So let's mark that upthrust as U1. So U1 equals 4 over 3 pi R over 2 to the power of 3 rho g. Notice again the density I did not change. Why? It is for the liquid. Both are in the same liquid. So if I divide, this is the equation 2, equation 1 over 2 u over u1, if you 4 over 3 pi r3 rho g divided by 4 over 3 pi r over 2 to the power of 3 rho g. If you check these things carefully, these parts will get cancelled. This one cancels this one cancels this one, right? So it is r to the power of 3 divided by r to the power of 3 over 8. So 8 goes up. Answer is definitely C, right? Question number 5. They talk about power. Here you have to actually kind of ignore average word. Let's think about power. Power is energy over time. How fast you spend energy or you gain energy, right? But for a spring, if a spring has spring constant K and extended by extension is X, this elastic potential energy is half K X squared. We need to remember this equation. So when spring contracts, it loses this much energy. So power equals energy half kx squared in how much time? Delta t. So I can write kx squared 2 delta t. This is the power. This answer can be found as answer C. Question number 6. The mass is given and impulse is given. Now, we know kinetic energy equation. They are talking about kinetic energy. Kinetic energy is half mv squared. But momentum is, symbol is p. Now this mv squared, you can write mv squared total v total squared over 2m. Based on that, kinetic energy can be written as p squared over 2m. Now they ask kinetic energy, impulse or momentum is 2 squared over 2 times 5. If you look at this is 2 over 5, 0.4. Kinetic energy is an energy joule. So answer should be A. Okay. The mass of this ice is capital M. There's a mass of water and it is temperature at capital T. So when water, what happens? Ice will absorb this energy from water and water will end up at 0 Celsius, right? So change of temperature at the end will be T minus 0 or T. So by conservation of energy, heat given by water must be equal to heat absorbed by ice. So part of ice will end up being water, right? So water energy given is mc delta T means in this case T equals, let's think we don't know how much ice melts, m dash L. So m dash is mct over L. Be careful with the small m and capital M. Small m is for water, big M is for ice. So there's no capital M here in the answer, mct over L. So answer should be A. Question number 8. This is just your general knowledge. Greenhouse effect. Enhance. Be careful. They are talking about anthropological or enhanced greenhouse effect. So volcanic activity has nothing to do with us. Now these three have basically they are because of human interactions. But more importantly, we all know fossil fuels has big impact than cutting down the forest at the moment. Yeah, so answer is D. Question number 9. This is I find this question to be a difficult question. Ideal gas is held in a cylinder by a piston. The piston compresses gas rapidly. The average speed of gas molecules increases because the gas molecules. Now, one thing to understand is average kinetic energy of a gas molecule is 3/2 Boltzmann constant times temperature, right? This is about temperature. So unless you change the temperature, there's no way to increase the speed of molecules. That's very important to understand. Now, having a small volume, is it connected to this equation? No, it's only about temperature. So I remove answer A. And as this is adiabatic process, adiabatic means delta Q is 0. It means heat cannot enter, heat cannot leave the system. So there's no point of talking about energy transferring. And make more collisions every second with each other. This is actually more about pressure. It is not about the speed. Again, speed of a molecule is not related to pressure. So it is because the molecules actually absorb energy from the piston while it is rapidly moving inwards. So molecules come and it goes faster than it came back. It came to the piston. That's why answer is C. Question 10. They ask what is the total resistance of each combination of resistors increasing resistance. Okay, so we should have a smallest to the largest resistance. So resistor combination, that's not very difficult. This is R, 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 R. So this is 2R, this is R/2. So altogether 2.5R. In this case, if this is R, R and R, this is also R. So this total resistance is R/3. So 1.3R is the answer for second combination. The third one, this one is R, this is 2R. So total resistance is R times 2R divided by 3R, right? Plus R, that because there's another one in series. So if you look at this one, R plus 2/3R, or other words, you can say this is 1.7R roughly. So in that case, I can compare these three answers. One is 2.5, that's the biggest, and 1.3 is the smallest. So Q should be at the beginning. So Q should be at the beginning, and R should be the next one, and P should be the last one because this is the largest resistance. So in this case, Q R P. Question number 10, answer should be D. Question number 11, belt has a width and moving at 2.5 meters per second, and it has a charge density per square meter. What is the current in the wire? Okay, let's start. Current is charge divided by time, right? The problem is how much is charge. In 1 second, if you focus on 1 second, this total length will be covered. This total charge will be taken out by the wire, right? Now this area is 0.6 times 2.5. This comes to 5, 10, 15, 1.5 meters squared, right? Now charge density 1.5 times each square meter has 5 millicoulomb. So So this comes to 7.5 millicoulomb per second. Coulomb should be capital C. But current is charge over time. Charge is 7.5 in every second, so this should come to 7.5 milliampere. Because why I wrote 1? Because I focused on 1 second all the time. So time is 1. So answer for question number 11 should be 7.5. Intensity is power divided by area, right? Here, intensity is 0.15 kilowatt, right, per meter squared per second. So we can take it as 150 in watt equals power divided by area is 0.2. So power will be 30 watt. But this is the power given to the solar panel. So power output is efficiency times power input. So in this case, it should be 30% times 30. This should be 9 watt. Answer is C. Now, let's think about these two situations. This period is given in the data booklet. T1 is 2 pi m over k. Second thing to understand is this spring constant is actually twice of individual spring constants. So this period, let's say T2, is 2 pi m over 2k. Now these are two simultaneous equations. So what you can do, see what they want to hear. They want to hear T2 over T1. So I divide 2 from 1. T2 over T1 is 2 pi m over 2k divided by 2 pi m over k square root, right? So T2 over T1, 2 pi m over 2k, and this goes up k over m, and there's another 2 pi, right? So this one cancels. So ultimately you end up with 1 over square root 2. So the answer should be B. Okay, this is the displacement and time graph for a particle simple harmonic motion. They ask frequency and amplitude. What can we get from this graph? We can get the period, right? Period is this value, and amplitude is the distance from the equilibrium point to the extreme point, right? So in this case, frequency is 1 over t. So that comes to 1 over 4 times 10 to the power of negative 3, 250 hertz. Amplitude should be obviously 5 nanometers. So answer for 13 is B. Now the question here is about Snell's law. What is Snell's law? N1 sin I is N2 sin R. This is Snell's law. N1 is the refractive index of first medium. I is the angle of incidence. So I am trying to write Snell's law for this point. Let's call this point as A. One thing to understand is these angles are the angles of the ray with the normal. So we need this angle. This is obviously 40. So this angle is 40. So let's write Snell's law. 5 over 3 sine 40 equals 4 over 3 sine theta. So sine theta comes to 5 over 4 sine 40. Theta is sine inverse 5 sine 40 over 4. Theta comes to 53. Answer is C. Question number 16 is about a car or any other wave source moving closer to you, right? So I sketch this diagram. This is the observer on red color. Now, first thing to understand is they are asking about how frequency difference to the initial frequency change, right? So let's think the car is emitting a sound wave of frequency 1000. First question we should ask is, when time equals capital T, when the car stops, what will be the frequency? Now this frequency also will be 1000 Hertz. Why? It's not moving. So in this case, at time equals capital T, there's no change of frequency. Delta F over F naught should be 0. Why? The frequency is the same like a natural frequency, so delta F equals 0. So the answer is 0. So we should find a graph which gives 0 at time equals capital T. Second thing, let's think about the numbers. F dash is F times V minus U is the equation for a source moving closer, right? So let's find out F dash. If it is 40, 1000 times 340 for sound, 340 minus 40, you will get roughly 1130 Hertz. So delta F equals 1130 minus 1000 is 130 Hertz, right? So we can see delta F over F naught should be a positive number because it is 130 divided by 1000. It's more than 0, right? So the value should be, so what I'm trying to say here is, if I go to left hand side, delta F over F naught should be positive and getting closer to 0. So that answer is only available in option A. Question number 17 compares gravitational field strength on surface of a planet relative to the Earth. So let's write an equation for the field strength on the surface of Earth. G equals Gm over capital R squared. But what is given here is diameter. Diameter is 2R. So G equals Gm over D over 2 squared. So equation changes into 4Gm D squared. That is for the Earth. Let's take it as a first equation. Now if you read carefully, you will see Earth is 18 times, the mass of Earth is 18 times, and the diameter of planet is 1/3 of the Earth. Now for the planet, we will write equation again. G P equals 4G. Mass is 1/18th m over 18th, and the radius or diameter is D over 1/3 squared. So this becomes 4Gm D squared times 9 over 18. So this is actually 4Gm 2D squared. Let's take this one as 2. If you divide 2 from 1, you will get G of the planet on the surface is actually G over 2. Answer is B. The unit of epsilon naught and mu naught, these are permissivity and permeability of the medium, the electric and magnetic constants. So easiest way is to look at the data booklet. Data booklet has their units, but the problem is we have to understand what they are asking is in SI fundamental units. So let's think epsilon naught mu naught is units are c squared n negative 1 m negative 2 times t meter and ampere -1. So I will put Tesla and C squared and others as M and ampere and Newton. But if you think about Tesla, let's use F equals BIL equation to get the unit of B is, which is called Tesla, actually is Newton, ampere and meter. So I am going to use this number, I am going to substitute for Tesla. And again, let's think about, Coulomb. Coulomb is the unit of charge, right? Charge is current times time. So Coulomb means actually ampere second. So let's combine all these together. So Newton, ampere meter means Tesla, ampere second squared and meter, ampere and Newton. If you look at this one carefully, we'll see Newton gets cancelled, right? And so it is ampere squared, second squared, below the line ampere squared, meter squared. Again, ampere gets squared gets cancelled. So the unit is S squared M -2. So answer here, you have to be careful. C and D both look similar, but correct answer should be answer A. Now we know the force on a current carrying wire in a magnetic field when it's perpendicular to the magnetic field is given by F equals BIL. We have to modify this one a bit for the change of force B due to change of current and times L. So in this case, force increased by 4 millinewton. Okay, I am keeping it as 4. B current is 5. L is 0.32. You can ask, why don't you change this one into Newton? Because I am trying to get B. If I don't change it to Newton, I'll get in millitesla, right? So 4 divided by 5 times 0.32, answer is in millitesla. So this answer comes into 2.5 millitesla. Answer is A. Now in this question, negative charge carriers travel counterclockwise in a circular path. Let's focus on this point on your right hand side, right hand end of the circle, and let's think it's moving upward here. But we know current is into the opposite direction of a negative charge carrier's motion, right? So the current is downwards in this point and magnetic field is into the page. We have Fleming's left hand rule for these situations. If you place your middle finger, thumb finger and point finger perpendicular to each other, and point finger, when point finger represents magnetic field and middle finger represents current, thumb finger will give you the direction of force. So use that concept here. Using your left hand, you will understand there's a force on this wire to the right. Similarly, if you do the same on the other edge of the loop, you will see there's another force towards the left hand side of you. So this happens everywhere. So the loop gets kind of pulled outwards. So definitely this loop will end up, if it is possible, if the force is big enough and the loop is light enough, it will get into a bigger diameter. So answer should be C. Question number 21. This is a common question in IB. First thing to understand the background knowledge is, when an electron falls from a high energy level to lower energy level, energy decides the frequency of the photon, or you can say the energy of the transition decides the wavelength of the photon, right? So let's think we understand there are two photons which are pretty similar here, and they have high increasing wavelength. So these are small wavelength, so these are strong or high energy photons, but pretty similar, right? Let's think that can happen if you look at this equation. Let's see this fall of an electron, let's call it a fall for the sake of understanding, and this fall, the energy wise they are pretty similar. These two falls represent these two lines. Similarly, there are two more falls like this one and this one are again similar but small energy. That's what represents these two lines. Now let's think something else. Let's think answer B. Answer B should show, according to this energy level diagram, it should have three photons which are pretty similar in energy. So this diagram should give emission spectrum with these kind of similar three lines. Similarly, here this should give three lines. This should give actually 2, 3, 4, 5. There should be 5 very similar lines on a spectrum. So we can see these two lines are given by only answer A. Question 22 is about the nuclear notation. Nuclear notation, we use X and we write A here, Z here. Z stands for proton number. A stands for mass number, which is proton plus neutron. So this question's confusion is, what is this 54 electrons? In nuclear notation, we don't care about electrons. If the electron number is different from proton number, the atom will end up being an ion. But that's not our problem. We only care about protons and neutrons. So in this example, the notation should be number of protons is 53 and number of nucleons means protons and neutrons all together should get into 142. Forget about electrons. Electrons is not relevant in nuclear physics, so answer should be A. In a nuclear power station, we have fuel rods which contain either uranium or thorium basically, and then we have a system to stop this or control this reaction, and we call them control rods. These black ones are control rods and these are fuel rods. The problem is these fuel rods actually generate high-speed neutrons. The problem is if the neutrons are too fast, they will just pass through these other nuclear fuel rods, and they will not interact with these other nuclei. So to slow down this process, the speed of the neutrons, we have a medium in between which can actually slow down the speed of the neutrons, and this medium is normally H2O or water. Sometimes they use graphite also if it is a dry medium. So why H2O actually is a good question. Oxygen and hydrogen. This hydrogen is actually similar to a neutron. So they interact very well with water. For that, we need water to slow down the neutrons. So answer is D. Question number 24 is actually an extension of question number 23. Let's think you have example. This is a random number. If you have 5 neutrons coming out of a reaction and 0 absorbed by whom? I am not talking about the fuel rod, by walls. What happens? Now this becomes a chain reaction. Why? There are too many neutrons coming out. This 5 will be 25, 25 will turn into 125. This is very dangerous. So chain reaction, we want chain reaction, but in a controlled way. This is very dangerous. So let's say you have 5 neutrons and all 5 are absorbed. Then what happens? Reaction will stop. That's also not good. We want reaction to happen. So in this case, the best case scenario is 5 neutrons. If 4 are absorbed and 1 can continue the reaction. So this is the best case scenario. In this example, if you have 1 and that one is absorbed, that's not good. If you have 2, 2 are absorbed, not good. And if you think about answer B, you have 1, 3 are absorbed. It's not even possible, because to absorb 3 there should be 3 released, right? So answer should be C. You have 2, 1 is absorbed by the walls of the nuclear reactor. Question number 25 is pretty simple. It's from option B in all syllabus, which is D equals 1 over P. This is parallax angle, and D in this case is 1 over 0.01, 100. This is called parsecond. Parsecond is actually bigger than light years, much bigger than kilometers. So this is another way of measuring long distances in astronomy. So answer for 25 is D. These are my answers, and if you need any clarification or if you like to comment on this, please do so. Thank you very much.